Here's problem 913. A 10-gram bullet moving horizontally with a speed of 2 kilometers per second strikes and passes through a 4 kilogram block moving with a speed of 4.2 meters per second in the opposite direction on a horizontal frictionless surface. If the block is brought to rest by the collision, what is the kinetic energy of the bullet as it emerges from the block? Let's imagine what we have going on here. We've got a bullet moving to the right. Mass of the bullet, we'll call it M1, is 10 grams or 0.01 kilograms. Velocity initially of the bullet is 2,000 meters per second. It's going to collide with a block that's moving in the opposite direction. Mass of the block is 4 kilograms. And velocity 2 initial is moving at 4.2 meters per second, but since it's in the opposite direction, we'll have to write that as a negative 4.2 meters per second. So this is what is happening initially. Now, after the collision, the block comes to rest. It's got a hole in it, and the bullet has passed through the block. And V2 final, or V1 final, is, we don't know. That's what we want to find out, because we need to find the kinetic energy of the bullet based on that. But this is mass 1. Here's mass 2. V2 final is 0, because the block came to rest as a result of the collision. This is the way things look like finally. Alright, let's set up our one equation to rule them all, namely conservation of momentum, for this problem. We have that mass 1, velocity 1 initial, plus mass 2, velocity 2 initial, equals mass 1, velocity 1 final, plus mass 2, velocity 2 final. The initial momentum equals the final momentum. In this case, we have 0.01 for the mass 1 moving at 2,000 meters per second, plus mass 2, which is 4, moving at a negative 4.2, supplying negative momentum to the situation. That should equal mass 1, 0.01, moving at some final velocity, which we don't know, plus mass 2, 4, moving with a final velocity of 0. It came to rest. So this term is 0. So what we have is 2,000 times 0.101 is 20, minus 16.8 is equal to 0.01 times V1 final. Or V1 final is equal to 3.2 divided by 0.01, or 320 meters per second. So that is the final velocity of the bullet. We want to know the kinetic energy of the bullet as it emerges from the block. So we want to find the final kinetic energy of the bullet. So K1 final would be 1/2 mass 1, velocity 1 final of the bullet squared. That's going to be 1/2 times 0.01 times 320 squared, and that gives me 512 joules. So the kinetic energy of the bullet as it emerges from the block is 512 joules.